So hello students, welcome to the online lecture for hydraulics. As we've already discussed in the introduction part about the topics which we will cover in this subject. So let's start. So what is fluid? The basic definition for fluid is anything which flows or have a tendency to flow is known as fluid. But the proper definition for fluid is anything which have a tendency to flow under action of some external force. It should have some external force, then it is known as fluid. So in fluid mechanics, basically fluid are of two types, liquid and gas. In fluid mechanics we will study about the three phase of fluid. First is fluid static, means when the fluid it is in rest. Fluid kinematics, when fluid it is in motion. And fluid dynamics, when fluid is in motion and it causes motion too. So let's start. So the basic properties of fluids we will study. We will study the techniques which are used for pressure measurement, and we will study about the buoyancy and flotation. What are the basic difference? So let's start with the properties of fluid. So first property of fluid is mass density, or you can also known as density, which is denoted by rho. So rho is given as mass upon volume. Its unit is kg per meter cube. The standard fluid whose density is known is water. So its density is 1000 kg per meter cube, or in CJ system it is 1 gram per centimeter cube, and it is at 4 degrees Celsius. Second property is specific weight. It is also known as unit weight or weight density, denoted by W or R. So its formula is, it is weight upon volume. So unit becomes Newton per meter cube, but when we simplify it further, W becomes M into G by volume, because weight can be written as N into G. So W becomes rho into G. So we can find out the value of unit weight for water and other fluids. So for water, W becomes 1000 into 9.81, because density of water is known 1000 and gravity is 9.81. So the specific weight becomes 9810 Newton per meter cube. We can also calculate for other fluids. Third is specific volume, which is denoted by V or capital V. It is volume per unit mass. So becomes, it is reciprocal of density also. The unit becomes meter per kg. Fourth one is specific gravity or relative density. It is the ratio of weight density of fluid by weight density of standard fluid. So standard fluid becomes water. For any other fluid whose weight density is already known, so formula becomes rho of fluid into G upon rho of standard fluid into G. So G becomes cancel out. So there is a note. So it is a unitless or dimensionless quantity, because in both the denominator and upper it is same. So for liquid, standard fluid is water, because water is present everywhere. It is 1000 per kg per meter cube. For gases, it is air. Its specific gravity is 1.21 kg per meter cube. So specific gravity of water and mercury at 4 degrees Celsius is 1 and 13.6 respectively. So this value should be known to you. Now another property of fluid is viscosity. So viscosity is basically the resistance which is offered by one layer of fluid over another adjacent layer. So it is known as viscosity, because it is basically the resistance offered. So there is, Newton has given a law for that. So Newton's law of viscosity is that shear force tau, it is directly proportional to the velocity gradient, that is denoted by del U by del Y. So by putting a coefficient value, that is mu, we gets the formula tau equals to mu into du upon dy, that is velocity gradient. So here mu is the coefficient of viscosity, or it is also known as dynamics of viscosity. So unit for mu, that is coefficient of viscosity, is Newton second per meter square. Okay, so it is also given in Pascal here. So mu in terms of Pascal is mu equals to Pascal second. In CGS it is known as dyne. So dyne second per centimeter cube per centimeter square becomes poise. So 1 poise equal to 1 dyne second per centimeter square. So further viscosity is divided into two parts, that is kinematic and dynamic viscosity. So kinematic viscosity is denoted by mu. This it is equal to dynamic viscosity divided by the density of fluid. The unit for kinematic viscosity is Newton second per meter square whole divided by kg per meter cube. It is the unit for density. So on simplifying, it becomes meter square per second. So the value or unit for kinematic viscosity is meter square per second. In CGS system it becomes Stoke. So unit for CGS unit for kinematic viscosity is 1 Stoke. So what are the different effects of temperature or viscosity? So in case of liquid, viscosity is due to the cohesive force. So when the temperature rises, the viscosity decreases because the cohesive bond or force decreases because the particles tends to move away from each other. So viscosity decreases in case of liquid when temperature is increased. In case of gases, viscosity is due to the intermolecular momentum. So therefore the rise of temperature, the viscosity increases. So in case of liquid, viscosity decreases due to rise in temperature, and in case of gas it increases on rise of temperature. So that's all for today. In future lecture we will learn about the surface tension, buoyancy and flotation. So thank you.